In part 1 of the video, we talked about how we can divide radical expressions. We talked about various examples of that. We focused on this idea that sometimes radical expressions are better to work with in fraction form, like examples E, F, and G, and sometimes it's better to work on them where you have roots of each individual piece. If you have not watched that yet, you're going to want to watch that before you begin this video, because in this video we're going to operate under the assumption you understand those things. I want to talk to you about some no-nos in radicals. There's a few things you've got to make sure are true about your radical expression if you want it to be simplified. There are 3 things we look out for. Number 1, in order for a radical expression to be simplified, you have to remove any perfect squares from underneath the radical. In other words, if you can square root it, you must square root it. Rule number 2 is a new one. You cannot have radical expressions in your denominator. Radical expressions in the denominator are very difficult for us to work with, so we make a point of eliminating those. Lastly, rule number 3, you are not allowed to have a final answer that has a fraction underneath your radical, or in the radicand, according to technical terms. Now, when we're trying to remove a radical from the denominator, we use the term rationalizing to explain the process. Take a look here. In example 1, radical 5 over radical 7 violates rule B. No radicals in the denominator. So I need to get rid of it. I'm going to use a cool little trick involving the identity property, which says, identity, if I can spell, there we go, which says one of 2 things. The identity property of addition says if you have a number and you add a 0, the value of the number does not change. The identity property also says if you have a number and you multiply it by 1, the value of the number does not change. I'm going to use this second version, multiplying by 1, in order to change the way that this fraction looks without changing its value. So, radical 5 over radical 7 is going to get multiplied by 1, but remember 1 can take a lot of different forms. I can write it as a 1, I can write it as a 2 over 2, I can write it as a 3 over 3, I can write it as a 4 over 4. All of these are different ways of writing the number 1. I'm going to use a very specific way of writing the number 1. I'm going to write it as negative 7 radical over negative 7, or wow, I can't even talk. Radical 7 over radical 7. Do you know why I chose this version of 1? If I multiply those together, it gives me a radical 35 over a radical 49. Do you know why I like that? Because radical 35 is irrational, but radical 49 turns into a 7. This is considered to be simplified because there's no fractions under the radical, there's no radicals in the denominator, and there's no perfect squares hiding inside of this radical that I can get rid of. As kind of an extension, it's worth noting that dividing by 7 is the same as multiplying by the reciprocal 1/7. So you're going to find that a lot of people write this as 1/7 radical 35. If you feel comfortable with that, you may want to try example 2 on your own, 3 over radical 2. If you're uncomfortable with that, you may want to watch me do it again. This is in violation of Rule B. Rule B says I'm not allowed to have radicals in the denominator. To get rid of it, I'm going to multiply by 1. It's going to change the way this fraction looks without changing its value. But the version of 1 I pick is very specific. Do you know what I'm going to use? Radical 2 over radical 2. Do you know why I chose that? The numerator is 3 radical 2. The denominator is radical 4. And radical 4 is a perfect square. Notice that dividing by 2 is the same as multiplying by a half. So for that reason, I'm going to take this 3 radical 2 over 2, and I'm going to write it as 3 halves radical 2. Again, I'm going to continue progressing through these. You can feel free to pause at any time to try them on your own and then watch the balance of the video to see if you've done it correctly. I want to rationalize this denominator by multiplying by radical y over radical y and get radical 7y over radical y squared, which is radical 7y over y. Now, technically, this should be the absolute value of y because it's supposed to come out positive, but we're ignoring that point for just the moment. Example 4. In this one, I'm going to notice right off the bat that this is 9z radical z. I'm going to do that at the beginning just because it's going to make my number smaller to work with in the end. If you're not sure what I just did there, you need to go back and watch another video on simplifying radical expressions before you do this. I still have a radical in my denominator, so I'm going to multiply by radical 6 over radical 6. This is 9z radical 6z over radical 36, which is 9z radical 6z over 6. Notice, by the way, that 9/6 will simplify, and you end up with 3/2. So your final answer here is 3z radical 6z. I'm going to run out of room over 2. Example 5 violates Rule 3. No fractions under my radical. Because of that, I'm going to split it using my division property for radicals. Now it looks just like all the others. It's in violation of Rule B, which says no radicals in the denominator. So I'm going to multiply by radical 5 over radical 5. This is radical 15 over radical 25, which is radical 15 over 5. If you want to really impress me, take that divided by 5 and write it as times 1/5. Notice example 6 has a fraction underneath your radical. That's in violation of Rule C. I'm going to split it so that I have radical 5 and radical 12. Do you notice anything interesting about our denominator this time? Radical 12 is not in simplest form. Radical 12 is 2 radical 3. You're going to want to put that in simplest form before you start rationalizing the denominator. The reason for that is if you don't do that at the end, there's going to be a lot of extra work to simplify it. Much, much easier to simplify it at the beginning. I'm not allowed to have a radical 3 in my denominator, so I'm going to multiply by 1 in the form of radical 3 over itself. That gives me radical 15 over, this is 2 radical 3 times radical 3, which is 2 radical 9, or radical 15 over 2 times 3, or radical 15 over 6. Once again, if you really want to impress me, you're going to change that to multiplying by the reciprocal. I'm going to continue making those increasingly complex. If you haven't mastered those first ones yet, you're going to want to go back and look at those again. This is radical 2y over radical 5x to the third. This is not in simplest form. This is x radical 5x. If that confused you, you need to go back and watch a video on simplifying radical expressions. I want to get rid of the radical in the denominator, so I'm going to multiply by whatever's under that radical. This is radical 2 times 5 is 10xy. This is x radical 25x squared. That, of course, is going to simplify, so I'm going to come down here. Radical 10xy over x times, this is 5x. So your answer is radical 10xy over 5x squared. Last one. Once again, I would recommend pausing the video and trying this on your own and then watching the video to see if you got it correct. I can't have a fraction under the radical, so I'm going to split this in two. I noticed that the top is in simplest form, but the bottom is not, so I simplify the bottom. If that confused you, you need to go back and watch a video on simplifying radicals. I'm not allowed to have a radical 3b on the bottom. Getting tight in here. So I'm going to multiply by radical 3b on the top and bottom. That gives me, let's get over here where there's more room, radical 21b on top over b squared radical 3b, and 3b makes 9b squared, which is radical 21b over b squared times 3b, which is radical 21b over 3b to the third. Hopefully that's helpful to you. Best of luck.